Metals, nonmetals, and metalloids are three different types of elements that we will find existing on our periodic table, and really of every element that exists, they either are a metal, a nonmetal, or a metalloid. So this can be helpful for us to then identify their properties based on their element group, because all of the metals have certain properties in common, as well as all of the nonmetals, and that can be helpful to group them and sort them based on their properties. So our instructions today say complete the Venn diagram with the following properties for metals and nonmetals, then list the metalloids and their key properties. You'll notice in the Venn diagram the metals and the nonmetals are going to be different properties, but the metalloids will converge with shared properties between the metals and the nonmetals. So let's start with location on the periodic table. The metals are going to be found on the left side of the periodic table, and the nonmetals are on the right side. You'll start to notice that metals and nonmetals tend to be sort of opposites of each other in their properties. Even here on their location, metals are on the left, nonmetals are on the right. Next, we're going to look at some basic properties of metals and nonmetals: conductivity, malleability, ductility, luster, and magnetism. So let's just briefly describe what these mean before we put them into metals and nonmetals. Excuse me. Conductivity means that you have the flow of heat and electricity. So if you think like wires and things like that, or materials that heat up really quickly, that would be conductive materials. Malleability and ductility have to do with how bendy and stretchy our materials are, and luster has to do with how shiny. Magnetism has to do with the stickiness, if you will, of the particles due to their polarity. Okay, so let's start putting these into the correct categories. Metals have most of these properties. They conduct electricity well. That means they have a quick flow of heat and electricity. They're very conductive. And that's, again, why wires are made out of metal, because electrons can flow through them, which is what electricity is composed of, the flow and movement of electrons. They are also malleable, so bendy, and ductile. They can be stretched into a wire. They are lustrous, meaning they have shine, they reflect light, and certain metals are magnetic. Not all of them. In fact, only 3 elements on the whole periodic table are magnetic: iron, nickel, and cobalt. We used iron in our separation lab. Remember the little iron fillings that stuck to the magnets? So that would be a property of these few metals, but nonmetals, you won't find any that are magnetic. So in a similar fashion, you'll find that the nonmetals are opposite in all of these properties. So nonmetals are poor conductors, or sometimes we call them insulators, meaning they do not conduct electricity or heat. And rather than being malleable and ductile, they are what we call brittle. So they are quick to shatter and break. They are not shiny. Instead, we would say they are rather dull. And they are not magnetic. Okay, let's move over to the other side of our properties. State of matter at room temperature and melting/boiling point. The two of these are related to each other because the higher that the melting point is, the more likely we will find that element as a solid. The lower the melting point is, the more likely we'll be able to find that element as a liquid or a gas. So, all of our metals have really high melting points, which means we are going to find most of them as solids. There is only one element that's not a solid that is a metal, and that is mercury. Hg, mercury. Okay, and we said this is a result of having really high melting point and boiling point. Nonmetals, on the other hand, have a variety of states. So we'll start by listing out the liquids. There is only one liquid of nonmetals, it's bromine. And then there are a handful of gases. These are states at room temperature. So our gases, just naturally found as gases, are hydrogen, nitrogen, oxygen, fluorine, chlorine, and the whole group 18, which are called the noble gases. It's in their name. They're all gases. All of the elements in group 18. That would be helium, neon, xenon, krypton, all of those in group 18. And then we have solids. Those are all the rest of the nonmetals. The reason for this varied state at room temperature is because they have a relatively low melting point and boiling point for nonmetals. So more frequently they'll find them at room temperature as liquids or gases. Next, let's look at electron behavior and ion charge and reactivity. All of these are kind of related to one another. So in terms of electron behavior, we are asking, do these atoms, these types of elements, gain or lose electrons to follow the octet rule? And remember, the octet rule means that they're trying to get 8 valence electrons, or 2 if it's the first level, basically a full outer energy level. So our metals, they're going to have 1, 2 valence electrons, so it'll be easier for them to lose electrons, losing 1 or 2, to get to that previous energy level than to gain 6 or 7 to get to 8 valence electrons. So these will lose electrons easily, metals will. And nonmetals will have like 6, 7 valence electrons. They will end up gaining electrons to become stable with a full energy level. Or sometimes they'll share electrons as well. But metals tend to lose and nonmetals tend to gain. Because of this, as an atom loses electrons, that means its neutrality will be lost and we'll have more protons than electrons, causing it to become a positive ion. Metals form positive ions. And oppositely, if we're gaining electrons, we'll lose neutrality towards the negative side. Extra negative particles will cause it to become negatively charged. We'll have negative ions. Last category here is reactivity, which we looked at on our notes about periodic table arrangement. We want to go ahead and just kind of describe which groups are the most reactive for metals and for nonmetals. And remember, these are the groups that have the closest amount of electrons to a full valence shell, the closest to following the octet rule. For the metals, that is the alkali metal group that only has 1 valence electron. So our alkali metals are the most reactive metals. And the most reactive nonmetals are the ones that have 7 valence electrons. This is the halogens. Most reactive of the nonmetals. There's all of our properties for metals and nonmetals. Now let's do the second part of these directions to list the metalloids and then their key properties. Not all of these that we've listed are applicable to metalloids, which is why they kind of get their own instructions here. So our metalloids, there's only a handful of them, so we're going to actually list them all out. Remember, these separate the metals from the nonmetals. Boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. And these are on that stair-step line down the middle of the P block. One of the most unusual and also helpful properties of the metalloids, it's kind of a defining key property, is that they are what we call semiconductors. This is very helpful for technology, cell phones, computers, things that could easily overheat, but they need electricity. So we have kind of this intermediate conductor that will allow electricity to flow but doesn't overheat. And so those type of elements are really, really helpful for technology. So semiconductor is a key property of the metalloids. Other than that, all of the metalloids have a mixture of properties from both metals and nonmetals. So if you look from side to side, it can kind of pick and choose depending on the element. It'll have a little bit of both of the properties. The state of the metalloids at room temperature is always solid. And just like we said before, mixture of both, they can gain or lose electrons. They can do both. There's our summary of the properties for metals, nonmetals, and metalloids on the periodic table. Flip to the back side and you'll have a compare-contrast list. For each property listed, we're going to identify the element it best describes using the periodic table. The best way to do this is over here on the left side, determine if it's nonmetal or metal or metalloid. I like to use that distinction just to kind of help me then narrow it down on the right side. So my property here says found on the right side of the periodic table. In your Venn diagram, what type of element is that describing? That's a nonmetal. So then I'm going to look at the elements that's listed here and say, okay, which of these is a nonmetal? Well, magnesium is a metal, lanthanum is a metal, so it has to be oxygen. And then you can just circle your nonmetal, oxygen it is. Low melting point. Again, look at your Venn diagram. What type of elements have a low melting point? Nonmetals. So then do the same thing. Sulfur, manganese, and zinc. Sulfur is the nonmetal. And you'll just do that for each of these. Some of them, it doesn't apply to list metal, nonmetal, or metalloid. Like for example, in group 6, period 6, group 10, that one you'll just find the location. Use that periodic table to help you. You don't have to have these properties memorized. It is just kind of match the element type to the periodic table and to the Venn diagram for comparing and contrasting their properties.